Hi, this is Kevin Trainer, and I'd like to welcome you to my lecture on Chapter 12 of the Murach MySQL book, second edition, and Chapter 12 is entitled How to Create Views. I'm going to leave you to read the learning objectives on your own. And now we're right into the Create View statement. Now, a couple of chapters ago, I took a peek ahead, and in one of my demo tutorials, I showed you Create View. We were creating inline views with using a select statement in the from clause, and I went ahead and show you how to formalize that and create a view. So we've already seen this, but we're going to get some more details here. So here on slide 3, we're creating a view called vendors min as select vendor name, vendor state, vendor phone from vendors. And I guess what we're saying is that it doesn't have all of the columns. Okay, so it's a minimized version of the vendors table. So we're going to get all the rows, but only the columns that we asked for. 122 rows. And now on slide 4, we're going to select all columns from vendors min, where vendor state equals CA, ordered by vendor name. So we're getting the vendor name, vendor state, vendor phone, but only the vendors that are in California. Okay. We can update data based upon views only if the stars align. Okay, so we're going to learn here in the chapter that there are requirements that have to be met in order to issue an update against a view rather than one of the base tables. So here we're saying we want to update vendors min, set vendor phone equals where vendor name equals register of copyrights. I'm wondering if that's the registrar of copyrights, but we'll see. Okay, and at least in theory, that's going to work because that's going to meet the requirements that we're going to tell you in a couple more slides. And we can drop a view. So we can create a view and we can drop a view. So drop view vendors min, poof, it's gone. So some of the benefits provided by views: designed independence, data security, simplified queries, updatability. Okay. Let's talk about simplified queries. Okay. There are times when you need to join a lot of tables in order to get a particular view. In fact, a couple of weeks ago when I did the tutorial demo and I showed you how to create a view, I think we did 4 joins or 5 joins, and we created a view with 4 or 5 joins. Well, it's a whole lot easier to write a query against that view and not have to worry about all the technical aspects of doing the joins than it is to write the query with the underlying base tables that has all the joins. So that's what we mean when we say simplified query. By data security, here's what we mean, okay? There are features of SQL that are security oriented, okay? We haven't learned them yet. They're not included in the course as we're doing it in the current semester. Basically, different users are given different access to individual tables. And here's the kind of rights that they're giving. Um, at the top, you're given the right to be able to create new tables, to be able to create tables and drop tables, to be able to query the values in a table. Okay. Um, the lowest level, and there's the capability to be able to add rows, to delete rows. But the lowest level of capability you can get for a table is the ability to query and see all the columns in the table. Now, what if we wanted some of our users to be able to work with the whole table, but other users, we didn't want them to see something like a salary field? So what we could do is we could create a view that didn't include the salary field, and then we would give access to the users who we didn't want to be able to see and or change salaries. We would give them access to the view that had less to see, that showed fewer columns, that did not include the salary column. And in that case, we could implement a rough kind of data security. Now, in terms of real-world data security, most relational databases are used in support of application systems written in programming languages by developers, and the data security aspects are typically enforced by the applications themselves. And so in most relational databases, the application is providing its own security and not relying on the database security features per se. Okay, so this use case is, I guess, available, and it certainly might be something they wanted to use if you were, say, a super user who was working with MySQL Workbench as some kind of super user end user tool. But if you've got a group of developers that are going to write your application, this isn't quite so much of a consideration. The data security is going to be in the application itself. Design independence. This would allow you to do the following thing. You could take your table definitions, okay, and let's say one of the tables you think is going to be replaced by two or more tables later. Okay, we have a real simplified version of a table. Okay, well, here's what we could do. In the first implementation, we could just have the simple design of the table. Okay, and then we could create a view that essentially allowed you to see all the parts of the table. Okay, then later on, when we got more sophisticated, we could change the underlying base tables, and then we could change the design of the query that creates the view such that it's a more complex query, and yet the view itself, the data that it exposes, and the way that we would query that view would remain the same. Okay, so this would allow for our database design to become more sophisticated while our view stayed simple. And updatability, some views are updatable, as we're going to explore. Okay, so let's look at some of these syntax options here on slide 7. You can say, we can say create or replace. We can say either create view or create or replace. The good thing about create or replace is, let's say that we already have we've already used this view name and we're trying to redefine it. Well, or replace would allow us to use it without having to drop it first. Okay. So, create or replace view name, and then we can name the columns as, and then we have a select, and then optionally we can say with check option or with constraint, which we'll explore in a bit. Okay, so down on the bottom of the slide, a view of vendors that have invoices. So create view vendors phone list, that's going to be the name of the view, as select vendor name, vendor contact last name, vendor contact first name, vendor phone from vendors, where vendor ID in, select distinct vendor ID from invoices. So this is just a subset of the vendors that have invoices currently. Okay. And now here's a view that uses a join. Okay. I'm sorry. Here's a view that uses a join. So the first one was a simple query from a single table, the vendors table. Next, here's one that's taking data from two base tables, vendors join invoices. So we're calling it vendor invoices. We're selecting vendor name, invoice number, invoice date, invoice total from vendors join invoices on vendor ID. Okay. Now we got the same result through doing a join as we got with the subquery in the where clause, and we've explored that interchangeability a couple of times already in the course. We can have a limit clause. We can have an order by clause. Okay. So here's a case where we have we're calling it top 5 invoice totals as select vendor ID invoice total from invoices, order by invoice total descending limit 5. So that's how it becomes the top 5. Here's a view that names all of its columns. Okay, if we don't name our columns, then we're going to inherit the column names from the underlying select. But here you can see that right after we say create or replace view invoices outstanding, we have a list of column names. So we give 1, 2, 3, 4 column names. Okay. And it just so happens that the columns that we are selecting match those column names. But if they didn't, those column names would have overridden the column names that were used in the select. Here is a view that names just the calculated column. And how does it do it? Well, within the select, it has the calculation, and it says as balance due. Okay. This would be, I think, more typical syntax, at least for me. Here's a view that summarizes invoices by vendor. So create or replace view invoice summary as select vendor name, count of asterisk as invoice count, sum invoice total as invoice total sum from vendors join invoices, group by vendor name. So we're going to have run one row per vendor, and it's going to be grouped that way. Okay. So now we've seen that we can create really all kinds of views, and you can query a view just the same as you query a table. The only consideration that you should remember is that these views are dynamic tables. So anytime we use the view in a query, the product's going to go out and run the query that creates that view, and then hold that in a temporary table, and then run our query against that temporary table. And then, of course, when that's done, that temporary table will be thrown away. Okay, so if creating this table over and over again for a bunch of queries is inefficient for you, then that's the thing that you ought to consider. Now we're going to talk about what if you would like to be able to update a view. Well, you can't use fancy features in the query that creates the view if you want that view to be updatable. Okay, so if you use a distinct clause in the select, it's not an updatable view. If you use aggregate functions like we did, we just had the count and the sum. You can't do that. If we use group by or having, can't do that. If we use the union operator, it can't do that. So it's got to be a pretty basic view to be updatable. So here on slide 14 is a view that is updatable. So we're calling it balance due, and we're selecting vendor name, invoice number, invoice total, payment total, credit total, invoice total minus payment total minus credit total as balance due. Vendors join invoices on vendor ID where more than 0 is owed. Okay, now we issue an update against the view. Update balance due view, set credit total equals 300 where invoice number equals, and then we give that 998 string. Now that works, okay, because we didn't use any fancy features in the select that was used to define the view. And you can see that the response from the system is one row affected. Here on slide 15, an update statement that attempts to use the view to update a calculated column. Well, calculated columns cannot be updated. Okay? And when you really think about it, how would you update it? Because almost any calculation is really based on some kind of algebraic expression. And what you're really seeing in the view is, of course, the results of that calculation, of that formula. And then there are typically, or there might be, more than one set of values that would give you the same answer. And then how would you decide on what values to set? There's really no good way to do that. So you can't update a calculated column, as you can see from the response that we got. We have another constraint that we can add to this called with check option. And so this is an interesting thing. So we set up a view, and based upon the where clause, certain things certain rows are included in the view. Okay, so if when we define the view we say with a check option, You're allowed to do an update if it won't change the number of rows that the view query is going to return. If we change a value such that a row will not be included in the view that was included before the update, well, then that will trigger the check option and that will blow up. Okay, so let's look at this. We are displaying a row from the view for invoice number P-0608. So you can kind of see that there. And then we go to update. We're going to set the payment total to 400, and 400 is invoice total is 20,000. So the credit total is 1,200. The payment total is 400. That's only 1,600. We're still going to owe a lot. So that's not going to keep the row from being included in the view the next time. Fine, no problem. Even with the check option, you can still update the row. Whereas here, set payment total equals 30,000. Okay, that's going to be more than what was owed. That's going to mean that that row won't appear in the view, and that means that the check option is going to be triggered, and that's going to generate an error. Here's a statement that creates an updatable view. Create or replace view, IBM invoices, select invoice number, invoice date, invoice total from invoices. Where vendor ID equals 34, we're assuming that vendor 34 is IBM. Okay. Now, just because views are updatable, that doesn't mean that they're not subject to the constraints on the underlying tables. So any constraint in the underlying table, uniqueness, not null, foreign key constraints, all those things can cause an insert to fail. So we're going to insert into IBM invoices, and it turns out the values that we picked, there's a required field that we've not provided that doesn't have a default value. So what's going to happen is that whatever table this is going to be added to, which is probably the invoices table, it doesn't have a default value for a missing column. So you can't use views to defeat the rules of referential integrity and database constraints. Here on slide 22 is a delete that fails because of a foreign key constraint. Okay, so we're going to delete from IBM invoices where invoice number equals that string beginning with a Q. And it says we cannot delete or update a parent row if our key constraint fails. Because we've invoiced line items that point to this invoice. Okay, so we can't get rid of the invoice while we still have line items that point to it. So just because it's in a view, it doesn't mean that you can ignore the rules. And here are two delete statements that succeed. So we delete from invoice line items first, Then when we go to delete the invoice from IBM invoices, that works just fine because we do, we're not failing a foreign key constraint. Here's the statement that creates a view. Create view vendors SW, which I think means Southwest, as select all columns from vendors where vendor state is in California, Arizona, Nevada, New Mexico. Here's the statement that replaces view with a new view. Okay. And of course, we've got more states in there. We've got Utah and Colorado. And there's a statement that drops the view. Not too hard to drop. Okay. So I'm going to have a short tutorial demo on this that's going to do just a couple of things to warm me up. And I'm going to say bye until then. So bye for now.